Okay, so this is lesson 2.5. It's composite functions. This is a little bit trickier than operations on functions. It actually follows in the same section in the book, but it is a little bit harder. So let's talk about what composite functions mean. All right, so get this out of the way. All right, so composite functions basically are what we're doing is we're putting a function inside of a function. So you'll notice here, if I want this is a complicated definition, but if I want g of f of x, that's how that's read. Okay, that means I'm going to put the function f of x inside where the x is for g and solve it for g. I promise it's not as hard as it sounds, but it is a little complex. I also want you to recognize notation here. This one backwards. Okay, so the g dot f means g of f of x. It's the same thing as this notation. I prefer this one, but the book will almost always use this one. So you have to recognize both of them. Okay, so let's look at what, how we actually use this. It's not as hard as it seems. A little more complicated, but not as bad. So what this means is we're going to start with this idea. It asks us first to find g of f of 3, and then f of g of 1, and f of 0. So let's start with what our functions are. So these are the same functions we were using yesterday, remember? So f of x equals 3x minus 2, and g of x equals x squared. So, and please ignore the side, we'll do that one in a minute. We're going to start with the blue one, okay? So what this means is it's g of f of 3, and I like to write it this way because it makes it a little easier for me to see, g of f of 3. And so what I'm going to do first is I'm going to find the function inside first. This is working inside out. So I'm going to find f of 3 first. So you'll notice I found f of 3 by plugging 3 into my f function. So it's 3 times 3 minus 2. So f of 3 is 7. All right, so now I have found f of 3. f of 3 is 7. So now I have done the inside of my function. I finished that. So now I'm going to keep going. Well, what is g of 7? Because now I know that f of 3 is 7, so now I have to find g of 7. So I take that 7 and I plug it right into the g of x function. G of x function is x squared. I get 7 squared is now 49. Okay, so all I did was I worked my way inside out. This gets a little bit harder if you're not dealing with numbers, if you're dealing with letters instead, and we're going to talk about that a little bit later. But right now, just plug the numbers in and work inside out. So then this example over here, which we can already see the whole problem of. So f of g of 1 equals f of g of 1. That's a 1. I know I messed up when I was writing. Okay, so work inside out. So we're going to do g of 1 first. So I plug 1 into this equation, and I end up with 1 squared, which is 1. Now I want to find f of that. So I plug 1 into the f function, and I get 3 times 1 minus 2 is 1. Now those ones are usually fairly easy for people to do. But what happens if you're doing the function of itself? So we're just going to function it twice. So f of 0 means that I'm going to plug 0 into the f function. That function right there. No g's, just plug 0 in there. And I end up with negative 2. 3 times 0 minus 2 equals negative 2. And now I have to simply run the equation again. That's what it means by f of f. I'm going to do it twice. So now I plug negative 2 into the equation, and I end up with 3 times negative 2 minus 2 equals negative 8. And that's doing it with numbers. So why don't you try these on your own? Okay. Here are your functions. Okay, f and g, and you have to find g of f of 2 and f of g of negative 1. You should be able to do this. Okay, there's your solutions. All right. Example 2. All right, so this is embedding more than one function and operations all together. There's lots of different things going on here. So this gives me the function g of t equals t squared minus t, and f of x equals 1 plus x. And then it asks me to find g of f of 0 and f of g of 0, and then it wants me to add them together. again, working inside out. So we're going to look at, first of all, we're going to look at the very insides. Okay, f of 0 and g of 0. So f of 0, if I plug 0 into the f function, where the x is, I get 1 plus 0 equals 1. And then if I plug 0 into the g function, I get 0 squared minus 0 equals 0. So now I know what f of 0 and g of 0 is. Okay. So now I can do the second part of my function. Once I know this, I can plug it in. So now I'm going to do g of 1. 1 squared minus 1 equals 0. And now I can do f of 0. So 1 plus 0 is 1. Okay. And now I'm going to add those two together, and my answer is 1. So a little more complicated. You have to kind of work inside out. Find your own system that works well for you. You want to do all the g first, and then all the f, and then add them together, whatever you want to do. Find a system that works well for you. Okay, I forgot to put a practice problem for that one, so we're moving right on to example 3. So this asked me to find the difference between, and I don't think you're seeing this, but I'm seeing something over here. So of the functions ff and f of f. So I want you to notice the reason I put this in here is because there's a difference. Okay, ff, like this, means f times f. This means f of f. There are two different types of problems, and I want you to be able to recognize both of them. So if I have the function f of x equals x to the third, and I have both, I want to do ff and f of f. ff is multiplication, f of f, lots of f's, okay, is composite function, embedding them within each other. So let's look at what we're doing. So if I'm doing ff, I'm doing x to the third times x to the third. Those are my functions. I'm multiplying them together. Composite functions, I'm actually putting the function inside of the function. So it becomes x to the third to the third function, to the third power. Okay, and those have different answers if you remember your exponent rules. X to the third times x to the third is x to the sixth, and x to the third power is x to the ninth. And here's your example I want you to work on your own, your practice problem. And here's your solution. And I will see you tomorrow.